Welcome to Class TV. I am Alewi Tosin. Elasticity is the part 6 of the topic elasticity. We continue with our calculations, but this time around we're taking some calculations on Young modulus. I've explained throughout the concept of Young modulus that's given a ratio of tensile stress to tensile strain. Now, from this let's take the first question. A wire of cross-sectional area. A wire of cross-sectional area, that means our A is 6 watts times 10 raised to power minus 5. This is minus 5 here. 10 raised to power minus 5 meter square. And length, that's L, is 50 centimeter, which needs to be converted to what? To meter, and it will be 0.5 meter. That's 50 divided by 100. Stretches by 0.2 millimeter. That is what our extension. 0.2 millimeter. Converting millimeter to what? To meters will be divided by 1000. That will be 0.123 meter. That's 0.0002 meters. Now, under a load of 3000 Newton, that is our F is 3000 Newton. So we are told to find the what? Calculate the Young modulus of the wire. Now, to calculate the Young modulus of the wire, you can record that we said that what? Young modulus is given as tensile stress over tensile strain. Now, we can decide to find our tensile stress, which is force over area, or calculate our what? Tensile strain, which is what? Extension over what? Original length. But we also derived the formula then when we were treating Young modulus, that what? Our Young modulus can be as was force times length over area times what? Multiplied by extension. And we are all having these givens here. So let's go this way. Our force is what? Is 3000, and the length is what? Original length is 0.5 over our area. Area is what? 6 times 10 raised to power minus 5 multiplied by this is 0.002. Now our 0.002, okay, let me write it first. I have a message to pass there. Now, if you multiply this by this now, that will give us 3000 times 0.5, give us 1500. Now, over, you can write this as 10 raised to power minus 5 multiplied by, converting this to standard form now, is 2 times 10 raised to power 1, 2, 3, 4 minus 4. Now, you can say that what our Young modulus now will be 1500 over 6 times 2, 6 times this 2, then 10 raised to power minus 5 times 10 raised to power minus 4. 10 raised to power minus 5 times 10 raised to power minus 4. Now, so that one will obey law of indices. We will law of indices. So we can say that 2 here, this gives us 750, and you can also say that what 2. Okay, let's just continue with this. So we say that this will be 750 over 6 multiplied by 10 raised to power minus 5. Our times turn to plus minus 4. So which means we have a 750 over what? 750 over 6 times 10 raised to power minus 9. 10 raised to power minus 9. Now, so with this now, we can easily say that this means 750 over 6 multiplied by 1 over 10 raised to power minus 9. So 750 divided by 6 now. 750 divided by 6 will give us 125. 125 times 10 raised to power. From indices, this 1 over will become minus, open bracket, what? This over becomes minus 1 bracket minus 9. So minus 1 times minus 9 will give us 125 times what? 10 raised to power plus 9. That's 10 raised to power 9. 10 raised to power 9, which can be written as 1.25 times 10 raised to power 11. The unit for modulus is Newton per meter square. Final answer. That's 1.25 times 10 raised to power 11 Newton per meter square. So that's the first question. Hope you understand the steps. Now let's take this next example. Now, let's take the second example. A wire of diameter 2.8 millimeter. Diameter is 2.8 millimeter. If taking this, we are taking this now. 2.8 millimeter. Firstly, we need to present this in meters. Presenting this in meter now will be what? Will be 0.0028 meters. That dividing it by 1000. Okay? Now, suppose a weight W. That our weight W, weight is a force. Now the force is an unknown force now. Weight W. If the tensile stress is, if tensile stress in the wire is, the tensile stress in the wire is 2, that's stress now, is 2 times 10 raised to power minus 7 Newton per meter square. Now, we are now told to find the value of W, which means, what is the value of W? Which means we are told to find what? Our force. Firstly, we need to recall that tensile stress is equals to force over area. Now, why tensile stress is force over area? We were given the what? Tensile stress. Instead of us being given the area, we were given our what? We were given diameter. Now, our area here is a cross-sectional area of a wire. And the cross-sectional area of wire, cross-sectional area of a wire now is what? Is given as what? The area of a circle, which is pi r square. Now, for the area of a circle be pi r square, we are given diameter instead of being given what? Radius. Now, we need to use our radius, our diameter to find what? Radius, which is what? Radius equals to diameter over 2. So with this now, our radius will be, the diameter is what? Is 0.0028 meters over 2. Which means our radius will be 0.0014 meters. Now, why this is the radius now, we will now find the cross-sectional area, which is pi r square. So our pi now is 22, is a constant 22 over 7, multiplied by, what is our radius? Our radius is 0.0014 square. That's 22 over 7 multiplied by, what is 0.0014 square now will give us 1.96 times 10 raised to power minus 6. So multiply that by 22 and divide it by 7. So we have what? 6.16 times 10 raised to power minus 6 meter square. So that is the what? The area of the cross-sectional area of the what? Of the wire. Now, to now find our force now, we said our now tensile stress is force over area, like we wrote here. So recall that we were given tensile stress as what? As 2 times 10 raised power minus 7. Force is unknown, and our area is what? Is 6 times 10 raised power 6.16, sorry, 16 times 10 raised power minus 6. So if you cross multiply now, you have our force being equal to 2 times 10 raised power minus 7 times 6.16 times 10 raised power minus what? Minus 6. Multiply this now, we have what? This should be 12. Okay, 2 times 16, that's 32. Let me see that. 2 times 6.16 now should give us 12.32 times minus 6 plus minus 7 now to give us a 10 raised power minus 13. Okay, now that is the final answer. The force of the wire now, the force, that's the weight of the wire, is what? Is 12.32 times 10 raised power minus 13, which could better be written as 1.3232 times 10 raised power minus 12 Newton. This is in standard form now. Okay, our time is fast spent. Let's take, I will encourage us to use this question, this 5B, as home play. Try it on your own and then see what you will get when you are given new modulus and what? New length. I name myself Alewitosin. We continue in our next class, elasticity part 7. Thank you.